Good afternoon, everyone. So today I am going to cover only three questions which are based on Laplace transform. All three would require a different approach and they can be very helpful in solving many of the problems. Yes, so I suggest that all three questions you first try by yourself, see how you will be able to approach them, and then you can see the answers which I am going to discuss. So the first one says that I need to find the value of integral 0 to infinite e raised to the power minus ax sine bx by x dx. Now if you recall that, then we discussed a question where we talked about the Laplace of f of x by x. X is in the denominator, so we can think of that approach. So if you see Laplace of f of x by x, and if you use the definition, then it is 0 to infinite f of x by x e raised to power minus px dx, and there is a right hand side. Now if I put f of x to be sine bx, then I am very close to the answer. The only thing is that instead of p on the left hand side I need a. So let's assume that p tends to a, and in that case it becomes the left hand side is 0 to infinite f of x e raised to the power minus ax by x dx, and the right hand side is a to infinity f of p dp. This approach is very common. You can see many questions. I am not discussing them, but you can see many questions based on this approach. Now rest is simple. I just assume f of x to be sine bx, and then I know what is f of p. So it is b by b square plus p square. Substituting it on the right hand side, it simply becomes the integration of b by b square plus p square, which I already know. So it is tan inverse p by b, and then so it is tan inverse p by b because it is integration with respect to p. So b is a constant here, and it turns out to be b would cancel out, because when you do it b square plus p square, then 1 by b would also come out, and it is tan inverse pi by 2 minus tan inverse a by b. Yes, before moving to the next question, just the remark that you can try one more question in the same way. So compute 0 to infinity e raised to the power minus ax minus bx by x dx. Try to solve it by yourself. I will also provide you the answer. The answer comes out to be log b by a. So try yourself. Same approach. The next one says that show that Laplace of x cos ax. Yes, so again recall that we have already discussed Laplace of xy. Yes, it is minus d by dp of, so that's why it comes out to be minus d by dp of Laplace of cos ax. Now Laplace of cos ax we already know. By substituting into the formula, it is can be easily proved. It has another part which says that compute L inverse of 1 by p square plus a square whole square. Now if you see above, then I already have in the denominator p square plus a square whole square. Yes, so if I take Laplace inverse on both the sides and rearrange some terms, so that I would have only, because if I separate the term which are related to p, or if I see it something like that, I can separate it in the form 1 by p square plus a square whole square, and the other term whose Laplace inverse is already known, then I am done. So think over it. So if I write it as p square plus a square minus 2a square, then it's quite easy, because it becomes Laplace inverse of 1 by p square plus a square. I multiply and divide by a, and I know its Laplace inverse. and the other term is Laplace inverse of 1 by p square plus a square whole square. I will take it on the left hand side and take x cos ax on the right hand side and simplify it. That gives me the required answer. Okay, the third question is very important. There can be many questions based on this approach. It says that I have to prove that 0 to infinite cos xt by 1 plus t square dt is pi by 2 e raised to power minus x. So this is again a very interesting application of Laplace transform, which helps us to solve many difficult integrals. If you directly try it, you will be stuck, but using Laplace transform it turns out to be very easy. So if I apply Laplace transform both the sides, then it becomes 0 to infinite e raised to power minus px and then this given integral. The only thing we need to remember is that whenever we are in such a situation, of course it is not solvable directly, we use the change of integration. Both the limits are 0 to infinite, 0 to infinite. Changing the integration won't create any problem. And in that case, e raised to the power minus px would go with dx. So it becomes integration of e raised to power minus px cos xt dx. Now think what it is. It is simply the Laplace of cos xt. If we realize this one, then we are done, because we know the Laplace of cos xt or cos tx, the integration with respect to x, it means t is a constant. So Laplace of cos tx is p by p square plus t square, and then I have 1 by 1 plus t square. Now using the partial fraction, I can easily solve it further. So rest is very easy, which can be easily solved. So I told you that this is very interesting approach. We can try one more question based on this approach, which says that again f of x is 0 to infinite sine xt by t dt is equal to pi by 2. So try it, use the same approach, find the Laplace of f of x and then use the change of integration. So this is dx. So now if you change the integration, then you will have the Laplace of sine xt. So e raised to power minus px sine xt dx and then 1 by t dt. So this becomes the Laplace of sine xt, which is t by p square plus t square, and this becomes 1 by, and if you solve it further, it simply turns out to be 1 by p pi by 2. This part is already there in the previous question also. When you solve Laplace of f of x, it turns out to be pi by 2 multiplied by 1 by 1 plus p. Now I need f of x, so I take Laplace inverse on both the sides, and I know that Laplace inverse of 1 by 1 plus p is e raised to the power minus x. And here I have Laplace inverse, so f of x is pi by 2 and Laplace inverse of 1 by p, which is 1, so the answer is pi by 2. Okay, so that's all from today's class. Thank you very much.